January 27, 1967. 3 astronauts, a sealed capsule, and a routine ground test at Cape Kennedy. But inside Apollo 1's newest spacecraft, a hidden flaw turns minutes into disaster. 100% oxygen, cabin pressure rising, and a hatch that refuses to open. What went so catastrophically wrong that a rehearsal claimed 3 lives? The truth behind the Apollo 1 fire is more disturbing and more consequential than most people realize. Virgil Gus Grissom, Edward H. White II, and Roger B. Chaffee brought together a rare mix of experience and promise. Grissom had already flown in space twice, first with Mercury and then as commander of Gemini 3. He was known for his sharp instincts and unfiltered honesty, a test pilot trusted by his peers and engineers alike. Ed White, an Air Force lieutenant colonel and engineer, became the first American to walk in space during Gemini 4. His calm under pressure and technical skill made him a natural choice for Apollo's inaugural crew. Roger Chaffee, the youngest, was a naval aviator and reconnaissance pilot. Though new to spaceflight, his reputation for precision and humility had quickly earned him respect within NASA. On January 27, 1967, these 3 men prepared for what was supposed to be a routine plugs-out test at Cape Kennedy's Launch Complex 34. The mission, officially designated AS-204, was meant to simulate launch conditions with the command module disconnected from external power and life support, hence the term plugs out. This was a critical milestone, a dress rehearsal before the planned February launch. The rocket itself sat unfueled, and the test was not considered hazardous by program managers. But trouble began early. Communications between the crew and ground controllers were plagued by static and dropouts, forcing repeated holds and adjustments. Hours slipped by as engineers worked to resolve the glitches. Inside the sealed capsule, the astronauts waited, running through checklists and troubleshooting as best they could. Each delay added to the strain, but the crew pressed on, determined to see the rehearsal through. The technical challenges would soon prove to be more than just an inconvenience. They were a warning sign that went unheeded as the evening wore on. Inside the Apollo 1 command module, every detail of the environment worked against survival in a crisis. The cabin was pressurized with pure oxygen at 16.7 pounds per square inch, more than 5 times the partial pressure of oxygen in normal air at sea level. In this atmosphere, materials that would barely smolder on Earth, Velcro strips, nylon netting, paper checklists, foam pads, and even the insulation on electrical wiring became highly flammable. Laboratory tests after the accident showed that a spark or even a hot surface could ignite these components almost instantly when surrounded by high-pressure oxygen. The cabin interior was lined with Velcro patches to secure tools and checklists, and nylon netting covered storage areas and equipment. Polyethylene insulation wrapped countless wires and hoses, running in tight bundles through the module. None of these materials had been rated for fire resistance in pure oxygen. Engineers relied on the legacy of earlier spacecraft, where similar materials had not caused issues, but the scale and complexity of Apollo's systems created a new level of risk. Escape from the module depended on a 3-piece hatch that opened inward. To release it, the crew had to equalize cabin and external pressure, then unlock and remove each panel in sequence. Even under ideal conditions, this process took at least 90 seconds. In a fire, as cabin pressure surged, the hatch would jam shut, impossible to budge from inside. The design, inherited from Mercury and Gemini, was intended for structural strength, but it left no margin for rapid egress. In the event of any ignition, the combination of flammable materials, high-pressure oxygen, and a slow, inward-opening hatch created a deadly trap. At 6:31 p.m. Eastern, a sudden power drop flickered through the Apollo 1 command module's systems. 9 seconds later, Roger Chaffee's voice broke through the static. He shouted, "Fire!" The urgency in his call was unmistakable. In the lower left section of the cabin, near the environmental control unit and beneath Gus Grissom's seat, something had gone catastrophically wrong. Investigators later found evidence of electrical arcing, damaged Teflon insulation on silver-plated copper wires, likely exposed by repeated movement of a small access door. In the oxygen-rich air, a single arc was enough. Flames erupted almost instantly, feeding on Velcro patches, nylon netting, and the polyethylene insulation that lined the cabin. Laboratory tests confirmed what the crew had no time to realize. In 100% oxygen at 16.7 pounds per square inch, materials that barely charred in normal air turned into explosive fuel. The fire raced across the floor, up the walls, and through cable bundles. Within seconds, the cabin's pressure spiked. The hatch, designed to open inward, became an immovable barrier as the pressure differential locked it tight. Chaffee's transmission was joined by frantic shouts, calls for help, desperate attempts to escape. The pad audio captured the chaos as the fire flashed over, consuming the cabin in less than 20 seconds. Biomedical telemetry flatlined. Outside, pad crew heard the muffled alarm and scrambled for the hatch, but the inferno inside had already sealed the crew's fate. The speed and ferocity of the fire left no margin for survival, transforming a single spark into a runaway disaster. Pad leader Don Babbitt and technician Jim Greaves reached the sealed command module within seconds of the alarm. They found themselves facing a wall of thick, acrid smoke pouring from the hatch seams. The heat radiating from the capsule was intense enough to scorch their faces through protective gear. With visibility near zero and the roar of the fire inside, every second counted, but the inward opening hatch would not budge. Pressure inside the cabin had climbed so high that it pinned the hatch shut, making the standard release sequence impossible. 3 pad workers tried in vain to unlock the outer panels, coughing and struggling to breathe as fumes filled the white room. The rescue team cycled in and out, gasping for air, hands burned by hot metal. Even with all available strength and tools, it took more than 5 minutes to force the hatch open. By then, the fire had consumed most of the oxygen and left behind a toxic mix of carbon monoxide and superheated gases. Medical teams arrived as soon as the hatch gave way, but there was nothing to be done. The official autopsy found that Grissom, White, and Chaffee died from cardiac arrest caused by inhaling poisonous fumes, carbon monoxide, and other combustion products, long before the flames could reach them. Burns were mostly sustained after death. The rescue attempt, though immediate and desperate, could not overcome the lethal combination of pressure, heat, smoke, and a hatch design that left no room for error. The tragedy left pad crew shaken, their testimonies later describing the hopelessness of those minutes and the haunting knowledge that nothing more could have saved the Apollo 1 crew. The Apollo 204 Review Board delivered a blunt assessment of the disaster. Their investigation catalogued a series of hazards built into every layer of the program. The use of pure oxygen at high pressure for ground tests was called out as a critical error, amplifying the flammability of materials that filled the cabin. The board found that Velcro, nylon netting, and polyethylene insulation were not properly tested for fire safety in these conditions, and they created a cockpit where a single spark could become deadly in seconds. The hatch design required time-consuming manual steps and opened inward against pressure, leaving the crew with no realistic chance of escape. Emergency procedures were found wanting, and hazard analysis was described as inadequate. North American Aviation, the prime contractor, faced sharp criticism for inconsistent quality control, incomplete documentation, and unresolved engineering flaws. The board's findings made clear that these were not isolated oversights, but systemic failures demanding sweeping reform. In the aftermath of the fire, NASA engineers and program leaders overhauled the Apollo command module from the inside out. The old three-piece inward-opening hatch was replaced with a single outward-opening design that could be released in seconds, even while the cabin was under pressure. Materials that had fueled the blaze, including Velcro, nylon, and flammable insulation, were removed. In their place, a new woven silica fabric called beta cloth lined the cabin and covered the crew suits, providing strong resistance to fire. Electrical wiring and oxygen lines were rerouted and shielded to minimize the chance of sparks or leaks. For ground tests, NASA abandoned pure oxygen at high pressure and switched to a carefully controlled mixture of oxygen and nitrogen to reduce the risk of combustion. Quality control and safety oversight became central to every stage of assembly and testing, with strict protocols for documenting changes and verifying compliance. These reforms were not just technical. They represented a new, program-wide commitment to astronaut safety at every level. Every launch today carries the legacy of Apollo 1's loss, from emergency hatches to flame-proof suits and checklists born from tragedy. Vigilance, not technology alone, defines safety. As new missions push farther, the smallest oversight can still cost lives. Progress in spaceflight remains written in risk and in remembrance.